Hello students, today we will discuss concept of gradient of a scalar field. So before going to this topic, first we will discuss what is dot product of vectors and cross product of vectors. Suppose there are two vectors A and B. So dot product means all of you know that is A dot B is equal to AB cos theta. And A dot B is equal to A1 B1 plus A2 B2 plus A3 B3. That means I cap dot I cap is equal to 1 and I cap dot J cap or J cap dot K cap, these will be 0. So when theta is equal to 90 degree, the A dot B is equal to 0. And the example, so there is another factor, that is suppose the A and B having two vectors, and this is the theta angle, and this angle is 90 degree, then projection of B, this is along A vector, so B cos theta into A. Now the second picture, the 90 degree angle is this, so the projection of A vector is along the B vector, and here the result will be A cos theta into B. So both the answer will be same because it is a scalar quantity, it has no magnitude. And example of scalar product or dot product is work done, that is F dot R, applied force dot displacement, or power, that is GWDT, that means applied force dot velocity, etc. Now what is cross product of vectors? That means two vectors having angle theta. So A cross B is equal to AB sin theta n cap, where n cap is the direction of the cross product. N cap is the unit vector perpendicular to the plane of this plane, and it obeys the right hand screw rule. So when we do A cross B, that means the screw is rotating from A to B. So that is why the n cap direction is in the upward direction. But when we do B cross A, that means the screw rotates from B to A. So that then the n cap direction is in the downward direction. So A cross B is equal to minus B cross A. And using this determinant, we can find out the value of A cross B. Now triple product of vectors. Suppose this is a parallelepiped and its size is A, B and C. So scalar triple product is equal to the volume of the parallelepiped. So what is volume of the parallelepiped? That is area of the base into height. So area of the base is A cross B and height is this. So height, that is this unit vector perpendicular to this plane. This makes angle phi with this C side of the parallelepiped. So that means this A cross B is equal to C cos phi. So C dot A cross B, that means this is the area of the base into the height. Height is C cos phi. So C cos phi into A cross B, that is C dot A cross B. And what is vector triple product? This is A cross B cross C, that is B dot A dot C minus A dot B dot C. Now we will introduce another operator, that is called del operator or vector differential operator. What is this? This is the I cap del del x plus j cap del del y plus k cap del del z. This del del x, del del y and del del z, these are called partial derivatives of x, y and z variable. That means suppose we want to determine del x, that means only the x will be the varying component or variable component, keeping y and z constant. And when we do del y, then only the y will be the variable quantity or component, x and z is constant, are constant. And when we do del z, then only the z will be the variable component, x and y will be the constant. So these are defined as partial derivative. Now according to the partial derivatives, that is the d psi, that means the total change in any scalar function psi is equal to the del psi del x dx, that means the partial derivative into the dx displacement, plus del psi del y dy plus del psi del z dz. That means suppose there is there is a r vector having the psi wave function. So when we go to the small distance change, that is dx, dy and dz, so the change in psi will be d psi, and we can rewrite this d psi is equal to the del psi dot dr, where dr is the infinitesimal displacement vector. So again we can write d psi is equal to a b cos theta form, that is a dot b, that means del psi dot dr is equal to mod del psi dot mod, we go into mod dr cos theta. So when this cos theta equal to 0 degree, then cos theta is equal to 1, that means the maximum rate of increase of this scalar function d psi dr maximum, this is equal to the magnitude of the gradient of a scalar field. So here this psi is a scalar field, that means it has only magnitude, no direction. And when we take this gradient of a scalar field, the answer will be the result will be the vector quantity. Now the concept of gradient. So here I have already discussed, that is the del psi. Del is a vector differential operator. When it operates on a scalar field, that is the psi. So the del psi is equal to I cap del phi del x plus j cap del phi del y, or plus k cap del phi del z. Phi or psi, any scalar quantity. Now we want to discuss what is the physical significance of this concept of gradient. So here, this is one example. So here, this is a mountain. So when we are with any person is going to upward direction, then the slope is positive. So uphill is positive slope. So the gradient of a this height is a scalar function. So height change in upward direction, the gradient will be positive, and when this person going in downhill, then the slope will be negative direction. So that means the gradient of a height, that is a vector quantity. Another example is air density gradient. All of you know that the air density is a scalar quantity, but air density gradient around the earth, this is a vector quantity. Why? Because all of you know that at the sea level the air density is maximum, and when we go to the higher altitudes, the air density will be that gradually decreases. So at the higher altitudes the air density is low, and at sea level air density is uh, maximum. So when we go to the higher altitudes to the sea level, the air density gradient will be positive, and vice versa. Now the temperature. So temperature is a scalar field, but gradient of a temperature, this that means heat flow, it is a vector quantity, because the heat flow always flowing, it always flows from hotter body to colder body. That means higher temperature to lower temperature, and when the two bodies having same temperature, heat flow will be stopped. Now the last example of a gradient of a scalar field, that is a equipotential surface. That means suppose there is a plus q charge, so the electric lines of forces are outward direction, and any surface over which the electric potential is constant, this is called equipotential surface. That means these are the equipotential surface, and the lines of forces are perpendicular to the each surface. That means these lines of forces are perpendicular to the each equipotential surface, and two equipotential surfaces can never intersect with each other. And these electric lines of forces are outward direction, whereas the electric potential, it decreases with respect to the distance. That means at the center electric potential is maximum, and when it goes to the um, uh, wider region or r varies, then the electric potential decreases. So the electric potential gradient is, it is inward direction positive, whereas the electric lines of forces are outward direction. So that is why E is equal to minus del V. Here minus sign refers because the electric lines of forces and the gradient of electric potential, these are equal and opposite direction. Now we will discuss another important topic, that is directional derivative. So suppose there is a e cap or unit vector that is along a specific direction. So suppose there is a r vector, so e cap is equal to r vector by mod r, and the directional derivative is the del psi, that is gradient of a scalar field, dot this unit vector along a specific direction. That means the component of del psi along this e cap direction, that is del psi dot e cap, this is known as directional derivative of psi along e cap. So we will discuss one numerical to clarify this directional derivative more appropriately. So find out, this is this problem. So find out the directional derivative of this psi. See, this is the scalar function at minus 1, 1, 2 in the direction of this r vector. So first we want to evaluate, that is the del psi, that is I cap del x plus j cap del y plus k cap del z, and this is the psi function. So this is the del psi, and at point x is equal to minus 1, y is equal to 1, and z is equal to 2. The del psi is equal to this minus 14 I cap minus 4 j cap plus 3 k cap. And what is the n cap or e cap? That is the r vector by mod r. So the directional derivative is equal to del psi dot n cap or e cap. And this is a scalar quantity. The answer is minus 38 by 3. Now there are another numericals, that is a and b, two vectors. So find out the n cap direction, unit vector perpendicular to the vectors a and b, and also find out the angle between the vectors a and b. So for this numerical we have to do first the cross product, and the what is the n cap direction, unit normal vector, that is a cross b by mod a cross b. So this is the answer. And what is the theta? That is we can measure, or you can find out the theta by either cross product or dot product. The answer will be same. So for sine theta, this is the formula, and theta is equal to around 62 degree. Now another problem. So three adjacent sides of a vector, suppose ABC. So what is its volume? So we can simply do the scalar triple product, that is A dot B cross C or B dot C cross A or C dot A cross B. The answer will be same. And using this determinant, the answer will be 12 units. Now there are another problem, that is for what values of m are the following three vectors are coplanar. So what is the condition of coplanar? That is the scalar triple product will be 0. So we will do the a dot b cross is equal to 0. So from these we can easily find out the m is minus 1. Now the last problem, that is if phi is equal to 3x square y minus y cube z square. So find out the del phi at point 1 minus 2 minus 1. So this is the del phi. We do the using this del operator, and the answer is minus 12 y cap minus 9 j cap minus 16 k cap. So today we will end this lecture here. Thank you.